Thank you. Thank you so much for having me here. I believe this is the clicker. So, thank you for the kind introduction. I want to talk to you today about research that we've been doing to try to understand or lay the ground for understanding the impact of AI on work. And it turns out there's lots of guesswork. And as you know, there's a scary article every second day talking about how computers are going to take our jobs. But we really don't have much data to back all of this up or to even investigate what this question means. So a bit of background about myself. I'm a computer scientist by training, but I now work in an Institute for Human Development. I'm one of the directors, which has traditionally been run by education specialists and psychologists. And the reason they hire the computer scientists is because we bring tools from computer science, cognitive science, and also physics to try to shed light on questions that have to do with the impact of technology, information technology, on human society, the economy, social interaction, and so on. So today I'll talk to you specifically about the future of work, and many of you may be familiar with some of these classic books now about the rise of the robots and machine learning and its impact on automating various tasks. So my colleague at MIT, Eric Brynjolfsson, and Andy McAfee have written one of those most popular books, The Second Machine Age. And one of the things they said is people are racing against the machine, but many of them, this is a losing race, because you can't do the repetitive tasks that machines are really good at better than machines. The answer is to race with the machine, so to complement what the machine can do. But the question is, what is that? So I'm going to show you some kind of fear-mongering, if you like, some scary things about long-term kind of predictions about which jobs machines are more likely to take or to replace. And this is a study from Fry and Osborne at Oxford University that was extremely popular at the time. The study basically, what they did is they took job descriptions. They brought a panel of experts in machine learning and AI, as well as other fields, and they asked people to guess what is the chance that, given your knowledge of the technology and robotics and machine learning, what is the probability that a given job will be automated? And these people came up with some probabilities, and then they used, interestingly, they used AI to actually do prediction based on this data. So AI is predicting what AI in the future will take people's jobs. And they came up with these numbers. So for example, here we have recreational therapists would have a very low probability of being automated, or first-line supervisor of mechanics. On the other hand, things like tax preparer, cargo and freight agents, watch repairer, will almost certainly be automated in the near future, near to medium future. That's what they said. Now, these numbers are a little bit challenged, contested. There's been lots of other studies after that try to improve it, but more or less the story is the same. Some jobs are much more susceptible than others, and that the distribution of these jobs is a little bit bifurcated. So in the following sense. So this is the probability that a job is going to be computerized on the x-axis. And on the y-axis is the national employment, right? This is in the US, I believe. And as you can see, there are lots of jobs on the right side and lots of jobs on the left side, and not much in the middle. So what this says is there are lots of jobs that are at great risk, lots of jobs that are safe, and nothing in between. And what you worry about is that the jobs on the right look more reddish, right? They have these warm colors. So there's certain types of jobs. So for example, service, sales and related, office and admin support, as well as farming and fishing and forestry are at a higher risk, whereas you could see that education, you guys are safe, legal, community service, healthcare, and so on have a lower probability of being automated. So the question now then becomes, well, suppose this is true, and I think a version of this is true, then how can we get the people on the right to move to the left? So how can we get the people who occupy all of these positions, all of these jobs, to move to the other side of this histogram, this distribution? And is it a smooth ride? So in other words, if we want to get them from the bad jobs that are at risk to the good jobs that typically are also better paid, how do we go about doing this? Is this a big jump? Is it a small jump? And so on. So in my research group, what we've done is we were trying to map what does this actually mean at the level of skills. And this has never been done before, because this idea of the hollowing of the middle class, the fact that these people with the middle-paid jobs, there's not so many of them, fewer and fewer. And the typical story is something like this, that economists tell. So economists will use wages as a proxy for expertise. So they would say, well-paid jobs are growing, as this thing shows. So in all of these countries, the high-paying jobs, the ones in brown, are growing. So there's a percentage increase in the proportion of these jobs. So that's good. Then you also see that low-paying jobs are also growing in proportion. But middle-paying jobs are going down, right? So they're actually losing market share, if you like. And that's kind of how you model or how you describe the hollowing of the middle class. But this is where it ends. But then we don't know what are these jobs? What are these middle jobs? What are these high-level jobs? Can we add some more texture to this picture? Because adding texture will allow us to say, well, what skills do we need to bridge this gap? So this exercise that we did has to do with networks, and I'm going to try to explain a very complex concept here, but hopefully in simple terms. The idea is that jobs, for example, these are example jobs on the left, accountant, insurance underwriter, crane operator, bus driver, and there are hundreds of these job categories. Jobs are composed of skills. So, for example, an accountant needs to know math, but also programming, and a whole lot of other things, but relies heavily on these two. Similarly, an insurance underwriter needs these skills too. A crane operator, on the other hand, might rely on multi-limb coordination, spatial orientation, being able to be very good at orienting objects and kind of judging distances and so on, and so does a bus driver. So you can take this, and this is a simplified cartoon, and you could build a network of skills that tells you which skills are complementary. So they always appear together in the same job. So, for example, math and programming have a strong connection because they complement one another. Jobs that require math often require programming and vice versa. You could say the same thing about these two skills, multi-limb coordination and spatial orientation, again, because they constantly occur together. Maybe something like programming and multi-limb coordination are a bit less likely to be connected, so that they have a weaker link between them. For example, in this case, only the crane operator would need both, right? But most jobs don't need both. So now if we take this approach and we conduct this exercise on 700 skills that are classified by the US Bureau of Labor Statistics or the Department of Labor, and then and the 300 job categories that they have, you get a network that's much messier than this. And the question is, what does this network look like? And I think that's where we saw this kind of surprise. If you do this exercise for exports, like you want to build a network of products that countries export together, you get something like this. These are not skills. These are products that countries export, and you could see that there is a core and a periphery. So on the periphery are things like fruit and raw materials, and in the center are these complex products that rely on one another. And we thought we were going to see something similar with skills. But what you see is something like this. It's a barbell, right? There's a big cluster on the right, a big cluster on the left, and a very thin bridge in between. So to remind you, every dot here is a skill. There's 700 of them, and the connection says that these two skills complement one another. And then we ran a clustering algorithm, which then generates this picture, and it shows you that there are two separate clusters. The cluster on the left has all of the skills that are social, managerial, analytical, like analytical problem solving, persuasion, management of conflict, and things like that. And on the right, you have sensory physical skills, like psychomotor skills, hearing, vision, glare sensitivity, things like that. And this was concerning because for us, this means that there are two islands, and you either sit in one of them or the other. And there's only a small bridge between them, so you cannot easily transition from one to the other. That was our hypothesis. And in fact, this kind of polarization you notice at the level of jobs as well. So we've done this analysis with jobs. So in this network, up the top, every dot is a job, and two jobs are connected if they're similar. Again, they're separated. And of course, we did some analysis at the level of cities, and what we want to do is we want to see which, in the case of the United States, where do the cities lie in this space as a whole, not just individuals in those cities. And I'll show you some kind of concerning picture. So you can take a dishwasher and say, what skills does a dishwasher rely on? And map it on this space that we built, this map. So think of this as a map, that shows there are two islands. And the question is, which island does the dishwasher live on? And it turns out the dishwasher lives mostly on the right-hand side, the sensory physical island. And this is the median income of a dishwasher in the US. Taxi driver has a few more skills on the left. So the ones colored in black are the ones that are used in this occupation. You could see now a chiropractor is a little bit more to the left, right? More increasingly so, but also paid better. And finally, a chief executive almost lives exclusively on the left island. And this relationship between income and the extent to which you rely on the skills on the left island is actually very robust, and there's a strong correlation between annual wages and the percentage of cognitive skills that you have. So there's the dishwasher, there's the taxi driver, chiropractor, and CEO. Now you could do the same exercise at the level of a city. So you say, I'm not just interested in whether a person is stuck on the bad island, but whether a city as a whole is stuck on the bad island. So you take all of the employment statistics of the city, you disaggregate it to the skills, and then you project them on this network. And you get something that looks like this. So I'm going to give you 3 examples from the US. This is Yuma, Arizona, a farming community. Detroit, it's struggling in between the two, and then finally New York. Very much comparative advantage of New York is in the cognitive and social skills. And again, these are the cities as seen on this plot that includes all of the cities in the US. Again, very strong trend. And as it turns out, education correlates very strongly with where you live. So this is the correlation between education level and the extent to which you rely on the skills on the right or the left. So you can see that education gets you to the left. And indeed, this is the case of different degrees, high school diploma, bachelor degree, and a doctoral degree. So with a bachelor degree, you already make a big jump to the good island. And the final piece of this puzzle is, well, does the fact that this network is polarized, does it actually make it difficult for people to move? So these are actual job transitions from the American Community Survey. This is a person who started off as a mechanical tool setter and then moved to a new job as a mechanic supervisor. You could see that this person was able to acquire a few more skills on the left, but not so many. The person is still stuck in the bad. So this person is making more money, but is still stuck in the same kind of cluster. A waiting staff is a bit of a mix because waiters have to interact with people, they need good social skills, and they're kind of one of the few occupations that straddle both sides. And this is a sales engineer who got demoted and became a retail supervisor, but despite the demotion, this person is still in the good place, right? Because in terms of the kinds of skills they're involved in. And it turns out, and this is analysis we're doing now with Erik Brynjolfsson separately, it's still unpublished work, that it turns out that those skills on the left are the ones that are safer, they are less likely to be automated, computerized by machine learning. If you're interested in this kind of picture and you want to play around with these networks, we built a website called the Skillscape. You could visit that, the skillscape.mit.edu. You could explore different cities. For the time being, it's mostly based, it's only using US data. But let me close by revisiting our question. We start, if a person starts from the bad island, where things are difficult, pay is not very high, and the prospects of automation are gloomy, because the robots are coming and the machine learning algorithms are coming. And this person, we want to take this person to the next level, to the good island. The question is, does it look something like a smooth ladder, where you can take step after step after step, or does it look like a less smooth ladder, where there are big gaps in the middle? And unfortunately, the story looks like a bit like the ladder on the left. I think what this means, from our perspective, and we still need to do more research to verify this, is that education is the only solution. You cannot make a jump on the job from the bad place to the good place. You need to acquire a bunch of skills wholesale together in order to make this jump. In fact, now we're developing a game, which we hope to launch early next year, in which we want to give people the ability to play this life game where you move from one job to another, and we want people to appreciate this idea that they're going to get stuck in one place unless they go and get education. So the game allows you to go get a loan for education, or go to university, or learn on the job, and we want to show people that which strategy is more effective. And with that, I think I'll close. Thank you.